Hello, scholars. Today we are starting a new unit, which will be all about gas. And specifically today we're going to talk about pressure and Boyle's law. So please take out a sheet of paper and a pencil, and you can label your notes gas unit, pressure, and Boyle's law. So if we start by thinking about what is gas, what do you remember about gas? How do they interact? How do particles interact? So some properties about gases are they assume the shape and volume of their container, and they have a lower density than solids and liquids. And then they also move very fast, and we can see them here in this picture colliding with each other. So why are we talking about this again? Well, we're going to be talking about the laws and how they apply to different things. We're going to start by talking about pressure. Pressure is the amount of force exerted divided by the surface area which it is exerted. And we can see here in this picture, all these particles are running into the wall of the balloon. There's a lot of pressure there. If we look at a bike tire pressure, you might have heard a tire pressure might be something like 70 psi, or pounds per square inch. How does that demonstrate force per area? We have all sorts of different units of pressure, and again, pressure is how often and how hard molecules collide with the surface. Make sure you write down this definition. Some popular common units are ATM, mmHg, kPi, torr, or psi. If you've ever had to put air in a tire, whether that be your bike tire or car tire, it was likely in psi or ATM. We're also going to be talking about temperature this unit. As a reminder, cold particles will move slower and hot particles will move very fast. And temperature is the measure of average kinetic energy of molecules. So a little more specific than what we've talked about before. And common units are degrees Celsius and Kelvin in the scientific term. A lot of times we talk about it in degrees Fahrenheit in America. However, chemists and scientists use degrees Celsius and Kelvin. Today, like I said, we're going to be focusing on Boyle's law. Boyle's law states that the volume of a given mass of gas varies inversely with the pressure when the temperature is kept constant. So our temperature is staying exactly the same, but then Boyle's law looks at pressure and volume. So if our pressure increases, our volume decreases. Again, inverse is the opposite. So then we see that there. We could also do the opposite. If your pressure were to decrease, your volume would have to increase. And our temperature is staying constant. Make sure you write this down, what Boyle's law is. So here, in this picture, if our volume is decreased, maybe it now is here, you have the same amount of particles, but there's going to be at a lot of pressure. And we'll look at some examples of this as well. A balloon with a volume of 2.0 liters is filled with a gas at 3 atmospheres. But now the pressure is reduced to 0.5 atmospheres, which is the same as ATMS, without a change in temperature. So if temperature is constant, what would be the volume of the balloon? So this is the original. So this we can call V1 because liters is volume. And then 3 ATMS is P1. And then here we have our P2. So we need to know the V2. So we can look at our equation. P1 times V1 equals P2 times V2. So we do 3 ATM, 2.0 liters equals 0.5 ATM times V2. So 6 equals 0.5 V2. So then 3 liters equals our volume. So notice when our pressure is less here, so then our volume is more than it originally was, because 3 is greater than 2. We can also look at these syringes. So maybe you've used syringes and notice it gets harder and harder to push them down, because as here our volume is really small, but our pressure is great. And here, the gas particles have a lot of space that they can collide with. The pressure is small, but our volume is great. We have more space. Deep sea fish is another example, and they often die when they're brought from the depths of the surface. The pressure decreases as you go up, which this is maybe something you've known because you have less pressure, less water pushing down on you. So the pressure decreases, which then increases the volume of gas in their blood, and then the fish die from that, which is really sad. And here are some examples of deep sea fish, but you may have heard that, they look much different than other fish, and that's because the pressure's so great lower, they had to adapt to that environment. Make sure you work on the IP, and you'll have a quiz on this material next week. Thanks for tuning in.